In this video, we'll focus on tangent lines, and we'll talk about some theorems, some special properties of tangent lines. So, before we get started, let's talk about some vocabulary. First off, let's talk about what a tangent is. Okay? In the geometrical sense, a tangent is a line that crosses, or I guess I should say intersects, a circle at one point and only one point. So, to kind of illustrate my point here, if we have a circle, let's call it circle C, and we have a point, let's call it T, okay? It is possible I could make a line that only just grazes the circle at one point and one point only. Okay? This point on a tangent line we call the point of tangency. Or you can think about it, it's the point where a tangent line intersects a circle. So now that we talked about tangent lines, let's talk about common tangents real fast. If we're looking at two different circles, let's say, for example, this red one and this green one, I can make tangent lines for each of them. So if we're looking at common, we're looking at which ones do they share. So I think in this case, we're looking at those two, but then we can also draw potentially two more. So this one has 4 possible tangent lines. Now for different circles, let's look at an example where perhaps the circles are already intersecting. Well then in this case there'd only be the 2. Or in the case where we have 2 circles connected by 1 point, again we're looking at the 2 from the one before, but then also we could draw one right between, so this one could have 3. Or if we're looking at concentric circles, well, then there wouldn't be any that I can draw there. So a common tangent, it's just tangents that 2 circles would have in common. So in the case of this first example, all the golden lines are tangent lines. In the case with the red, here's your tangent lines. In this case here with the blue, there's your tangent lines. And the last case with the concentric circles, there would be none. Okay, so now that we've talked about definitions of these tangents and common tangents, let's talk about a theorem. So there's only 2 theorems in this lesson. It's a little light on the theorems, a little heavy on the definitions. So, Theorem 1010, I'll read it word for word out of the book and then we'll talk about what it means. In a plane, a tangent or a line is tangent to a circle if and only if it is perpendicular to a radius drawn at the point of tangency. So there's a lot of words there. What it's saying is that if you have a tangent line, so in this case, if AB is tangent to circle S, then we can look at ST must be perpendicular to AB. That's all that that's trying to say. And remember, the if and only if, it also goes the other way. If I know this is perpendicular, then I know this is a tangent line. So if ST is perpendicular to AB and ST is a radius, then AB, the line, is tangent to circle S. So if we're looking at this, if we're thinking about how we could prove this, we're going to have to kind of think again with circles, we're probably going to use some triangles here. So something you could do to kind of help your point is, well, we make this radius to the point of tangency. You know, if we're looking at the red example first, if we're allowed to start with this being tangent, with AB being tangent to circle S, okay, then we're going to make some triangles to the line AB. And we can think about some conditions for them, but we can basically connect them and saying, okay, let's let these be equidistant from T, and we can call them X and Y. Now from there, we'll probably use some triangle congruencies. We'll probably end up using some way to show that these two green triangles I've drawn are congruent. And then if we can talk about the triangles being congruent, then we can talk about the angles being congruent, the angles at T. Okay, if we're going the other way, so if we're looking at, we get to start with just ST being a radius and going the other way with it. We don't know for sure that this is a tangent line. But we could do a similar kind of thing talking about triangles again and then walking through bit by bit. Ultimately showing that AB only intersects the circle one time at T. Okay, let's talk about theorem 1011. So, the book says, if two segments from the same exterior point are tangent to a circle, then they are congruent. So, I've already got an illustration up here. P is an external point. And if I think about how many tangent lines I can draw from the circle to P, there are two. There's this one from A to B, and there's this one from, or not from A to B, from P to B, and then the one from A to P. Okay? Now, ultimately what this theorem is saying is that if, as I have drawn it here, AP and BP are tangent to the circle C, and keep in mind I'm talking the lines AP and BP, then we're talking these segments. AP as a segment is congruent to BP as a segment. Now again, if we think about how we could prove this, we're probably going to go to triangles again. And something that might not be immediately obvious, but a helpful hint would be to make a line segment from C to P, and then also some radii from C to A and C to B. We know those two sides are the same. We know that this is a shared side. And knowing what we know about tangent lines and such, we can say that these are right angles, which then we can use Pythagorean theorem to say that, okay, if these two sides are the same, we could use Pythagorean theorem to show that the last two sides are the same. So that's how we kind of go through the proof, just thinking about why it's true. Ultimately, what we're being able to say is that if we have an external point and we make tangent lines for the circle, well, then it's the same distance between these 2 points.